Hi, I'm Sean Gannon, and this is Minute Math. And we got a triangle here, and we want to find the area of the big square. Now, there's some information about this triangle that we want to know. We got three squares that are within the triangle, and the big one right here, we don't know the area. We know the area of the smallest one being 9 units squared, and the medium one, which is, well, 25 units squared. So I'll call this medium, and this is small, okay? Just so we have a reference here. Well, with that information here, the small square's area, what's the length of each side? Well, we know that the area of a, square, asked here, the area of that big square is equal to 9, or small square, sorry, and that's equal to each side length squared, or 3 squared, right? And so the side length of each part here has to be 3. Now, what about the medium one? The area of the medium square, well, that's 25, which is 5 squared. So each side length here is 5. Okay? So what about the big square? If we know what its area is, we call it A. Its side length would be the square root of A, right? Squared gives me the area. So each side length would be the square root of A. So if I label it here, square root of A and, square root of A, let's do it down here. How would I break down each little part here? Well, if the overall length of this side length is square root of A, this little part right here would be square root of A minus a 3. And if this whole length is also square root of A, this little part here is, square root of A minus 5, the leftover part. Now, we got some triangles here. This is a triangle, we can see that here. And we know that since these two angles here are corresponding angles, these lines here are parallel from the square to the square here. These lines are parallel right there. That the corresponding angles will be congruent. And now we have, what does that tell us? Similar triangles. Angle, 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 angle. So because we have similar triangles, we know that their corresponding side lengths are proportional. We can make a ratio. So to do that, we have, 3 over its side length here of that triangle, square root of A minus 3 is equal to, right here, square root of A, that side length, minus 5 over this length leg, 5. Now from here we can cross multiply. 3 times 5 is that 15. And we have square root of A minus 5 times the square root of A minus 3. And now we can, try to solve for A here. 15 stays the same here. Let's multiply that out. Square root of A is just an A. Square root of A minus 3 is a minus 3 square root of A. Minus 5 square root of A is minus 5 square root of A. And last one, negative 5 times negative 3 is a positive 15. Now, we want to get A by itself here. So let's combine our like terms and see where we get. The 15s cancel out on either side, so we have a 0 here, equals, this is just a single A, minus 3 square root of A, and 5 square root of A is just a minus 8 square root of A. We can bring the 8 square root of A over to the left-hand side here. So we have 8 square root of A is equal to A. Now let's go rewrite that up here so we can see that in I guess we'll leave it in the same form. 8 square root of A is equal to A. I can square both sides here, and that gets rid of that square root here. 8 times 8 is a 64. Square root of A times square root of A is an A, equals A squared. Then from here, it makes it a little easier, you can divide both sides by A, and 64 is equal to A. And so A was the area of the big square, so our area of the big square is 64 units squared. And there you have it. Big area here of that square is just 64 units squared. Is this the answer that you got? If so, great. If it wasn't, well, I hope you learned something here and see how to solve this problem. I hope you liked this video. If you did, make sure you like this video and subscribe to our YouTube channel. This helps us make more of these fun math videos for you and for everyone else. So as always, thanks for watching.